This is part 2 of the EMF meter assembly guide. We will continue where we left off in part 1 and add the remaining coils, antennas, VU meter, wiring harnesses, and power. You will be using most of the tools used in part 1, with the addition of an optional power drill for winding a coil. The coils and antennas can be installed in any order you like. I'll be starting with the H-field detection coil. I've provided a 3D print file of the coil form. The coil is made with 36 gauge enamel-coated magnet wire, and you will need 350 turns of the wire. I used a drill with a wind cork cut down to fit the inside diameter of the coil form. I marked a line on the cork to indicate the starting position. I then began winding the wire onto the coil form in a back and forth motion. Repetitive video will speed up to shorten the time. Once you have completed the windings, twist the wires together and tin the leads. Depending on the enamel used to coat the wire, you may be able to use the soldering iron to burn it away as you tin the leads. Otherwise, you will need to scrape the enamel off using sandpaper or a knife edge. Once the leads are tinned, you can measure the coil resistance, and it should be about 27 ohms plus or minus 3 ohms. When you are satisfied with the coil, you can wrap it with mylar or electrical tape and solder a pair of wires to the coil for the final connection to the PCB. I used heat shrink tubing to insulate the connection, but mylar or electrical tape will work as well. Using hot glue, I attached the coil to the bottom of the PCB by the volume switches. You can also attach it to the other side if you like. Solder the wires to the L1 pads above the dip switch. Working with the antenna next, attach the P-clips to the antenna with a couple of 6/32 screws and nuts and lightly tighten them. Align the screws to the mounting holes of the PCB and tighten so the P-clips do not move. I used some 26 gauge red enamel wire to wrap around the telescopic antenna. 2 layers of wire are used. If you will be using this coil for H-field detection, then start the wire wrap at the top of the antenna, otherwise either end will work. Wrap the first layer as a single uniform wrap, keeping the wires close together between the 2 P-clips. Usually make the return wrap less uniform and random multiple layers to give it that hand-wrapped homemade look. Twist the wire ends together and tin the leads just like what was done for the H-coil, but no extra wire needs to be attached. These leads will solder directly to the PCB pads at L3. Note that if you decide not to insert this coil into the H-field circuit, you will need to jumper the L3 pads. Attach the antenna to the PCB and solder the wires to the L3 pads or add the jumper. The E-field circuit is too sensitive to use the telescopic antenna and would always activate at every touch. I recommend making an antenna out of the same wire used for the L2 coil, the 22 gauge plain copper wire, and cut about 1.5 to 2 inch length. Make a right angle bend at the end and then solder it to the AE1 pad. You can use some hot glue to secure the other end to the back of the dip switch. While you have the hot glue, you can add some to the LEDs to help secure them to the PCB. For the meter, I used a cheap Voltmeter from AliExpress. I've provided a 3D print file that works for this meter to create a new base. Start with the meter disassembly to remove the backing plate and meter element. Save the screws, you will use them later. The wiring of this meter is reverse polarity, so I swapped the wires so the red is now positive. After you print a label, use the backplate from the meter as a cutting template. Use a sharp scalpel blade to make the cuts. Use a black Sharpie marker to color in the edges of the label. I've tested a few types of glue and found that this Elmer's spray adhesive works the best. Lightly spray the back of the image and mount it to the meter base. I then lay the image face down on a clean sheet of white paper with a few weights and wait for it to dry. Once dry, clear the holes to mount the meter element. Use the same screws you removed earlier and mount the meter element to the base. The meter I used has a white plastic adjustment screw, and the TV series has a black one. The adjustment screw easily pops out of the cover and can be painted black. I used some Tester's black semi-gloss enamel paint. Hot glue the meter to the PCB. I placed 4 dabs of glue in the corners and some extra glue around the back hole. Solder in the VU meter wires, watching polarity. The speaker used is a slim type of about 2 watts and can be mounted to the back of either the 9-volt or the AA battery holder. Solder the speaker wires to the LS1 pads and hot glue it in place. This meter has 2 power options, either dual 9-volt or AA batteries. If you are using the 9-volt, just solder the 9-volt battery clips to the BT1 and 2 pads following the polarity marked, and screw in the battery holders with 3mm or 440 screws and 10mm standoffs. For the AA battery pack, it will require a 6-volt negative buck converter to provide the negative power source. This is also glued to the back of the battery holder. You will need to solder 3 wires, plus VI, ground, minus VO, to the buck converter before gluing to the battery holder. Once the speaker and buck converter are glued in, attach the battery holder to the PCB using the 3mm screws with the 10mm standoffs. As mentioned, 440 screws and standoffs will work as well. Solder the power connections as follows. VO minus of the buck converter goes to BT2 minus. G of the buck converter goes to BT2 plus. This was originally the negative supply, which is why the connections may seem backwards. The AA battery pack leads goes to BT1 plus minus for red and black. Make sure you have enough wires so the battery pack can be easily installed and removed from the holder. VI plus of the buck converter connects to the power switch pad as shown. A 9-volt negative buck converter is also available, allowing the 2 9-volt batteries to be connected in parallel and the negative voltage provided by the converter. The AA battery pack is easily inserted into the holder with the power switch accessible. Removing the battery pack is easiest by gently bending the holding clips away from the battery and giving a few shakes to let gravity slide the battery pack out of the holder. Add some black tape to the PCB top over the LED wires to match the TV series props. A length of black electrical tape cut in half lengthwise will work. There are a number of different wire routes used with the meters throughout this series. This table is just a sample of the ones I've found, including the pattern I used with these meters. Wire clamp locations have been marked in red. Jameco Electronics has a multicolor pack of 24 gauge wire that seems to be the best match to that used in the TV series. There is the 28 gauge rainbow ribbon cable, but it was smaller than I liked for this build. Once you determine your colors and routing pattern, you can either hot glue the end routes to the back of the PCB, or there are solder pads available that can be used for a more secure connection. .22 gauge enameled magnet wire seems to be about the right size for the wire clamps, but any available size should work. I just twisted the clamp wires and bent them flush to the PCB. I'll later cover them with some hot glue. The lower harness routes wire over and through the coil L2. You can bend some of the coil around the wire to better match the TV prop version. Note that the yellow wire is supposed to go through the hole to the right. I made that correction later. You are now ready to power up the meter. Check for any shorts in the power wires and set all the variable resistors to their midpoints. Set the dip switch SW2 so that at least one of the switches, 1 through 3, is enabled or in the down position. If you are just using 9 volts, then just turn the power switch on. If you are using the AA batteries, turn on the battery pack switch and then the power switch of the meter. While pressing and holding the test button, adjust RV1, the right side blue variable resistor, so that all LEDs are lit. Then adjust RV3, the black variable resistor, so the meter is in full deflection. RV2, the left side blue variable resistor, controls the overall gain of the meter and usually does not need adjustment. You should also have response from the audio circuit as you press and release the test button. The black rotary switch controls the E-field circuit, and depending on the switch type and position, it will set the gain and enable or disable the antenna. The dip switch on the side controls the H-field circuit. Switch 1 through 3 controls the gain from +10 to 0 to -10. Switch 4 enables or disables the L1 and L3 coils. I used an old wall transformer for magnetic field testing. Adjust the volume with the up and down volume buttons as needed. If it all checks out, you are ready to go ghost hunting. This completes the assembly of the EMF meter. Please check out the links in the video description for purchasing either blank circuit boards or assembled meters, and you can check out my GitHub for a detailed assembly user guide, schematic, and 3D part files. If you are interested in seeing the design process for this meter, please check out my other video here.